Hi, my name is Sloan Smith, and this is Experiment 1 for Physics 2212, Electric Forces on Tapes. The purpose of this experiment was to observe electric fields in action and calculate the magnitude of an unknown charge. To do this, we used Coulomb's law and modeled the tapes as both a point charge and as line charges. We found that we could find electric force by comparing it with gravitational force. We also found slight differences in the charges depending on if we used the point or line charge models. So the two models that we used are a point charge, which depicts all charge at one point in the tapes, or the line charge, in which charges are evenly distributed along the length of the tapes. For our experiment, we used a base tape to create two charged tape strips. We then observed how those charged tape strips reacted to other objects, such as a negatively charged pin. Finally, we used one charged tape to react with the other one to make it float against the force of gravity. You can see in the picture that one tape is beginning to float as my fingers hold it steady, the bottom tape steady. The tapes that were used were 20 centimeters long. The mass of them was 0.2 grams. The distance between tapes when one began to float was 2.7 centimeters. And the force of gravity was calculated to be acting on the top tape as being 0.001962 newtons. Therefore, the electric force acting on the top tape was also 0.001962 newtons. The charge on the top tape was calculated by hand to be 1.26 times 10 to the negative 8th coulombs, and it was a positive charge. The different models gave us two different answers for the charge on the top tape. The single point charge model gave us a charge of 1.26 times 10 to the negative 8th coulombs, while the line charge model gave a charge of 2.96 times 10 to the negative 8th coulombs. In order to calculate the charges, we had to assume that the tapes held the same total charge. For the single point charge, we went through and found the force of gravity and set that equal to the electric force. Then we went back and solved for using Coulomb's law. We used that electric force to find the magnitude of the electric field and back solved for the charge of tapes A and B that way. For the line charge model, it was more complicated. We used a loop to go through every single charge on the bottom tape and find the field it would have on the tapes in the top, using the original charge found in the single point charge model in order to get the original charges on the bottom tape. Using that looping method, we were able to get a different charge by finding the effect of the electric field on every single point of the top tape. For the discussions, we wanted to know what if electrons were positive and protons were negative, and we also wanted to compare the estimated value of the charges from the point charge model to the line charge model and look at why the two were different and which value was more likely to be accurate. For the first question, if the electrons were positive, then since electrons are what move between objects to give charge, when they moved, they would create excess or deficit positive charge. In the tapes, which had deficit negative charge originally, they would actually have deficit positive charge and would overall become charged positive. They would become charged negative. This would work for every other object, so the observed charges of every object would flip signs. When wondering about why the two models have different answers, we see that the line charge value is more than double the point charge value. This is because the line charge accounts for multiple small charges creating electric fields, rather than just assuming all charge has one effect at one point. The line charge value is most likely to be more accurate, as the charge would not realistically be centered entirely on one spot, since we charged the whole tape when we pulled it off the base tape. Thank you so much.